Okay, let's go ahead and start the topic, which is covalent bonding. Okay, before we start covalent bond, let's go ahead and review ionic bond. That's what unit we discussed like last time. So why atoms are forming bond? We know that every element needs a stability by acquiring 8 electron in their valence shell. So to get stability, normally for S and P block elements, we know that it needs 8 electrons. So 8 electron, that is the octet. So that's why atoms are reacting. Some elements, if they have electrons less than 4, they will lose electron. And if they have greater than 4, they will gain electrons. So say for example, sodium has 11 electrons, which has 2, 8 and 1 in the valence shell. So first energy level there are 2 electrons, second energy level 8 electrons, and last energy level they have only 1 electron. If they lose the last electron, this will become their valence shell and it will already has 8 electrons. So metals, you all need to remember metals always do what? Lose electrons. Non-metals can do both, but generally they have high electronegativity, so they will tends to gain electron. Okay. Then second question, it says what type of elements form ionic bonds? So that is also a review of what we learned last time. So we know that metals, which has low ionization energy, when combines with non-metals, they will form ionic bond because non-metals has higher electron affinity, high electronegativity. No metals have low value of ionization energy. So they tend to lose electron, and this one tends to do what? Gain electron. What happens to the electrons in an ionic bond? So we already said one metal, the metals are losing electron and non-metals are gaining electrons. So there is a complete transfer. There is a complete transfer of electron from one atom to other. That's what happening in ionic bond. Okay, so this topic is about the covalent bonding, okay? Covalent bonding, before we start, let's go review this one. Why do covalent bonds exist in our daily, where do covalent bonds exist in our daily life? Think about some examples which has covalent bonds. You all learned biology, so you know that all biomolecules are containing covalent bonds. So the first and most important example in our daily life, which is water, has only covalent bonds because it has hydrogen and oxygen, they are sharing electron. Then with sugar, or we can say all carbohydrates, proteins, lipids, generally we can say all biomolecules. So if you see in front of you, you have a paper in front of you. So paper containing only covalent molecules because it's a plant-based product. And you have a wooden table or desk. That is also contain only covalent bond. Okay. So we can see a lot of covalent compounds in the living substances. So just think about more examples from your daily life and write that and check whether they have covalent bonds or not. Okay, so We know that 17th group elements, which is this ones. 17th group elements, which is fluorine, chlorine, bromine, iodine. They have 7 electrons in the valence shell. They need one more to complete their electrons. And also 17th group elements, which is halogens, they have higher value of electronegativity, so they won't lose their electron, okay? So they need one more electron to complete their octet. But if there are 2 atoms, both of them have 7 electrons. None of them will lose or gain. So reason they both have higher electron affinity. Electron affinity is just opposite of ionization energy. It's the energy released when an electron is gained. Okay, they have higher electron affinity. So they don't lose electron. Both of them are needed electrons. So they will do what? They will mutually share their electrons. So the shared pair will be possessed by both of the atoms. It's owned by both the atoms. There are a couple of exceptions to the octet rule. We said everything need 8 electrons. Some of the atoms, because of their smaller size, they couldn't accommodate 8 electrons. Okay, the very good example is hydrogen. Okay, then helium, as you all know, it's a noble gas, they won't react. Okay, then lithium is there, but lithium is usually forming ionic compound. But beryllium, even though it is a metal, it has higher ionization energy. So usually most of its compounds they are sharing the electrons. So beryllium, boron, these 3. Okay, hydrogen, beryllium, and helium is also there. But I am not writing helium because helium won't usually react. Okay, so the most common thing you have to remember, hydrogen. Hydrogen has only one energy level, so it will only gain 2 electrons. Okay, beryllium has 2 valence electron. It will share 2. So beryllium usually get only 4 electrons. So hydrogen 2, beryllium 4, and boron, we know that it has 3 valence electron. It will share that 3, so it will get total 6 electrons. So they are not getting what? 8 electrons. Exceptions. Okay, let's go ahead and compare and contrast ionic and covalent compounds. Okay, so first one we said ionic compound is formed between what and what? A metal and a non-metal. Then covalent bond is formed only between what? Only between non-metal. So it is a non-metal and with another non-metal. Okay, then ionic compounds is what? It is transfer of electron from one atom to other. ES means electron. Okay, here they are doing what? They share electrons. So ionic compound is formed by metals and non-metals. Covalent bond is formed by between non-metals. The transfer of electron, they will share their electron. Okay. And so let's go and write an example. Say for example, sodium chloride NaCl, which is an ionic compound. Covalent compound, let's go and write H2O. Okay, or sugar. What is formula for sugar? Cetol H22O11. So these are examples. I'm going to erase it because I don't have space to write. Okay, then let's go and see the properties. We said ionic compounds are having very high melting point or boiling point, both. Boiling point too. But so if you have sugar at home, we know that we are easily melting sugar, it will get a brown color syrupy sugar syrup, okay? So generally, covalent bonds have low melting point compared to ionic compounds. Melting point or boiling point. Then conductivity, we already learned ionic compounds. Let's go right. Conducts electricity, conducts electricity only in liquid state. Conducts electricity in liquid state. When they dissolve or melt, they will conduct electricity because of what? Free ions. But covalent compounds never conduct electricity. There is an exception, which is graphite. Every other covalent compounds will never conduct electricity, never conduct electricity. They are called insulators. Reason, they don't have free electron or no free ions. So those are the property difference. So we can write more differences, but we are run out of space. Let's stop it here, okay? And these properties will be there on a lab and on your second AOL, okay? So that will be on your AOL number 7. Okay, let's go ahead and complete this one. I'm going to show you the electronegativity difference of different bonds, okay? On the slides, you can see a table with you will see a table like this. This one is actually giving the value of electronegativity of each atoms. So we can see fluorine is the one with the highest electronegativity and francium is the one with the lowest electronegativity, because we know that when you go to the right, the value is increasing, electronegativity is increasing, okay? And also when you go to the bottom, the value is decreasing. That's the trend we learned in electron trends, okay? So the highest value of electronegativity is on the right top left corner, but except noble gas. So based on the electronegativity difference, we can say which one has higher electronegativity, which one will form ionic bond or which one will form covalent bond. Say for example, an atom from here react with an atom from here, they have a very big difference in electronegativity. That means this will gain and this will lose and they will form an ionic compound. So go ahead and complete that. So the biggest difference we may see, it will be 4 minus 0.7, which is 3.3. Let's go ahead and write with a different color. Okay, so if the difference is above 1.7, electronegativity difference between two atoms, to up to whatever the maximum value possible, 3.3, they will be ionic compound. And if the difference between 0.5 to 1.7, that will be called a special type of covalent bond, which is called a polar covalent bond, okay? And if it is below 0.5, which will be non-polar covalent bond. Okay, so we will watch a video once I back. We will watch a video, or I will add a link to the video so that you can see what is the difference between that. Okay, so this question you can explain based on the table above, okay? Second question, how does a polar covalent compound differ from a non-polar covalent bond? So I'm going to teach you that, okay? So covalent compound, we said, say for example, An atom, say for example, fluorine has 7 electrons. Write with a pencil because I will erase this in a minute, okay? So both of this need 1 electron, so they will do what? They will share 1 electron in common. So after sharing, this one got 8 electron, this one also got 8 electron. Both of them are happy, they are sharing one pair. But if a covalent bond is formed between hydrogen and fluorine, hydrogen has 1 electron, fluorine has 7 electron. Sorry, that's it. Okay, so hydrogen need one more. We know that it is a special octet. Okay, so hydrogen need just one more. So hydrogen will do what? Hydrogen will share this electron with the fluorine. So I'm gonna draw with a different color. They are sharing one pair. So after sharing, hydrogen got 2 electron and fluorine also got 8 electron. Both are happy. But when you look at the electronegativity value, we know that the ability to pull electron, if fluorine has electronegativity 4 and hydrogen has electronegativity 2.1. So who is stronger in pulling electron? Fluorine. So what happened after few seconds, this is, imagine it is an electron cloud. Maybe I will highlight with the color. Okay, so this electron cloud, now it is equally distributing between two atoms, but after few seconds the fluorine will pull this electron towards fluorine. So what happened? The electron will slightly move towards the right. So hydrogen will get less electronegativities like this. Like if I am going to draw the orbital, I will show there will be more here and less here, like this. So that type of covalent bond is called polar covalent bond. Reason, since it is losing little bit of electron, I am going to give a positive charge because it is not completely gone. I can't give total positive. I am going to write a delta symbol. That is called partial. Delta means it is not complete, it is partial. So there is a partial positive charge here and a partial negative charge here. Partial negative charge here. So this type of compounds are called, one side is a negative and other side is a positive. The poles has charges, that's why it is called polar. So there will be two type of covalent bonds we are saying. Say for example, if two people which are equally strong sharing something, that means they will get equal amount of whatever they are sharing. That is called non-polar. But if a strong person is sharing something with a weak person, the strong person slightly pull whatever they are sharing towards him. So that will result in an unequal distribution of whatever they have. That type of bonds are called what? Polar covalent bonds. And this is very important. Because of the polarity we are all living. Otherwise, the water will be a gas. Yes, we will get into that in a minute. Okay. So we can use electronegativity values to determine the bond character. Okay. So I'm going to say high difference in electronegativity, they will be ionic. Okay. And very low difference or zero difference in electronegativity. Low or zero, which is less than 0.5. Zero difference in electronegativity will be non-polar. But if it is between that, okay, between that, which will be what? Polar. So that's why we are giving the values here. Okay. If the value of electronegativity is 1.7 or above, that will always completely transferring the electron and result in ionic compound. Or if it is less than 0.4, I would say 0.5, they will be what? Non-polar. But if it is 0.5 or above, but less than 1.7, they will form polar covalent bond. Okay, the periodic trend for electronegativity. Okay, what is the periodic trend? We know that when you move left to right, which is across the period, electronegativity doing what? Increasing. Electronegativity increases. So the higher value for always fluorine, noble gases are the exception. Top to bottom, okay? Top to bottom in a group, which is called a down in a group. You can write like that. Down a group. It is decreasing. We know that reason we already learned because of the nuclear pole. Electronegativity decreases. So that's why we said the higher value for fluorine, noble gases, exceptions. So higher value here. So if you draw a diagonal, okay, let me grab a highlighter. If you draw a diagonal, we can see it is increasing like this. The highest value is always on this side. Okay, that is the trend in electronegativity. So we can easily predict whether what type of bonds are forming. So now what you are going to do, you have to find these values and decide what the bond type. Okay, let's go ahead and do. I will do one example, then the rest of that you will do. Okay, you can pause the video there and to do it. Okay, so phosphorus, which is here, that is 2.1 and silicon is 1.8. So it is only, what is the difference? You just find the biggest value minus lowest value, which is what? It is almost 0.03. So we know that the range is, if it is less than 0.5, that will be what? That will be non-polar. You can write NP. Non-polar covalent, all that is covalent. Okay. Let's do cobalt. Cobalt is here, which is 1.9, and bromine is here, which is 3.0. So 1.9, 3.0, which will be what? 1.1. Yes. So you have to decide whether it is ionic or which one has. Sometimes you will think, oh, it is metal and non-metal. I know that it is co-ionic, but few examples will be there. There is an exception we are going to see. Say, for example, like beryllium and chloride, the difference will be, we know that that's metal and non-metal, but still the character will be polar, okay? So go ahead and complete that. And once you're done, start watching the second one, which is 1.2, naming covalent compounds. Okay, it is very easy compared to the naming of ionic compounds. Okay, there are only few rules, there are only 2 different types. Okay, so in covalent compounds, we know that there is no charges, so we are not using crisscrossing. So we don't know how many of each ions are there, because in ionic compound, we used the charges to decide how many of each ions needed by doing the crisscross method. But here, okay, here we don't have, let me pick a different color. Since we don't have charges, we have to tell others, okay, well, how many of each atoms are used. So you will use prefix to show how many of each atoms are there is, because they don't, why? Because they don't have charges, so we don't know how many are there to find it. Say, for example, this one. CO2, you will say carbon, and there are 2 oxygens. So the prefix we are using here, this is the prefix we will use di to represent 2. And second element, di for representing 2. And first element, we won't start a name with the mono. That is an exception, okay? But second element, even if it is 1, you have to tell it is 1 by using mono there. So right now, I'm going to give you the prefix. You have to memorize the prefix. It's not difficult, okay? I would say it is very easy. So if it is 1, the prefix we are using mono. Remember, we will never start a name with the mono. That means first element, if it is 1, you don't need any prefix. This will be 2 di, tri, tetra. Remember the tetra pack juice? Yes. Pentagon, 5 side, penta. 6 hexa, maybe that is hexagon, yeah. 7 will be hexa. 7 hepta, okay, that is a new word for you. And 8, we know that the prefix octopus, 8. 9, we learned 9 nano, so it is something similar. It is called a nona, okay. And the 10 will be deca. So on our syllabus, we are checking only up to deca, but there is 11 undeca, dodeca, trideca, tetradeca. There will be more, okay? So you have to memorize this prefix. I would say except this one, everything will be, you all familiar with, okay? There is mathematical terminology you can connect to, or just common real life examples, okay? Let's go ahead and start the naming. So, first element has a prefix unless if it is 1. We will never use mono to start the name. Okay? Never use mono on the first atom. Second element always has a prefix even if it is mono too. Okay, let's go ahead and do this. Says S4O2. Okay, start with the first element. Always start with the prefix. So I would say 4 is tetra, and tetra sulfur, and it is oxygen. Remember the rule for ending oxygen will be ide. All non-metals will be ide. Okay, second element will be ide. Right. Sulfur. Tetra sulfur. And how many? It is di and oxygen. Oxygen will be dioxide. Okay. So let's go ahead and do backwards. You have carbon. How many carbon? If there is no prefix on the first element, it is just 1 carbon. And it is fluoride. How many fluoride? It says tetra. So write CF4. Okay, now you do this one. Carbon. And how many? Tetra chloride. Next one, penta iodine tribromide. Okay, so first one is I, it has 5, and bromine is tri, it is 3. Okay, this is the tricky one. Okay, both are 1 each, but we will never start with the mono, so you will write carbon. And second element is 1, even though it is 1, we always use the prefix, so it is carbon monoxide. So those are naming. It's very easy. Go ahead and complete this one. Okay, just do 5 from here as a in class. Stop the video and 5 from here. I would say every other. Okay, every other. Do every other example. Like do 1 odd numbers. And the rest of them also you have to do, which is also homework. It's very easy, okay? And the only one thing, there is an exception will be there. I'm going to do those example, okay? So this one, you will get confused what is decoxide. And remember, it is deca plus oxygen. That is why decoxide. And if there is if there is A and O together, we will skip A. Go ahead and write that rule, okay? Skip A if there is A and O together. Okay. And if there are two O's like, say for example, mono plus oxide. You will not write monoxide. You have to skip one O there. Skip what? Skip one O. So those are the rule you have to remember, okay? I'll use that same highlighter color. So if there is an A and O together, skip A. If there is two O, skip one O. But every other vowels will stay, okay? Okay, so remember that when you write the name. So if you need an example, I'll write this one. We already wrote carbon monoxide, so this will be carbon. You won't write monoxide, okay? Instead you will write what? You will write monoxide. So that is important, okay? It's related to that. And let me see if we have an example with the deca. Don't have anything on the names, but here you can see the decoxide, which is related to this one. Okay? And there is also pentoxide. You can see that is heptoxide. You're skipping one A there, all those examples. Okay? And now, this is also a homework. It is mixed ionic and covalent compounds products. Okay? So, whenever you see something start with the metals, we know that which will be what? Ionic. Okay? So, go down, write all ionic first. Identify all ionic because they have a different terminology. But also, there is an additional thing I'm going to say. If you see a polyatomic ion at the beginning, that will be always ionic. There is a polyatomic ion. I would say we can pick that as an ionic compound. Okay. All ionic compounds contains metals or polyatomic ions. Ion means that is ionic compound. That's how we are doing it. Okay. So now go ahead and write the name. Both of them has different role. So first one, if it is an ionic compound, I would say it is just potassium and it is permanganate. No prefixes needed there. Okay. But if it is this one, it is a covalent molecule. So you have to say phosphorus triiodide. Okay, suppose the video for 15 minutes and finish that. Sorry, you don't need 15 minutes. It's 23 questions. Maybe do 10 minutes, okay? Do all other question and do the rest of that as homework. And again, that is also extra practice. That is also a homework, okay? Let's do that as a homework. If any questions, you can ask me when I come back, okay? Next one. It is types of covalent bonds. Okay, we said covalent bonds is formed by sharing electrons. Say for example, this one you can see chlorine on chlorine, they are sharing electron. Okay, based on how many pairs they are sharing, we can classify that into 3 types. Okay, let's go ahead and see type of covalent bonds. First one, hydrogen and hydrogen, they are sharing only one pair. So they will draw only one line in between them, which is called a single bond. So, why? There is an E there. Okay. So that is single bond. This one will be what? Yes, double bond. And this will be what? It is triple bond. So if they are sharing 3, that will be triple bond. Each bond represents the number of electrons, pair of electrons, say pair of electron. Number of electron being shared. Okay, so question, based on the strength, which will be the stronger bonds? Okay, look at this. This one has only 1, this one has 2, and this one has 3. So we know that which is ropes would be easy to break. So A will be easy to break because of the number of layers there. Okay, I need to write why. So more strands make stronger rope. Same thing. That is the one going here, okay? Same thing, there will be more shared per electron make a stronger bond. So which will be the strongest bond? So triple bond, yes. Triple bond will be the strongest bond. Difficult to break compared to single and double. Okay. Now let's go to the periodic table again. So remember when we colored the periodic table, we labeled them. So we wrote these 7 elements. Okay. These 7 elements are called diatomic because they always exist in nature as covalently bonded atoms. Okay. Covalently bonded atoms. Say for example, hydrogen will exist as H2, nitrogen will exist as N2, oxygen will exist as O2, F2 will exist as F2, Cl2 will exist as Cl2, Br2 will exist as Br2, like that. So they are called diatomic molecules. Diatomic elements are elements that exist in nature as diatomic. Okay, and what type of bond will be there? Is it polar or non-polar? They are equally sharing same atom. That will be what? Polar, non-polar covalent bond. Okay, so let's go ahead and study detailedly how to draw the Lewis dot structure. It is very important because there are so many things we have to learn from there. Okay, so I would go finish up to this one. Okay, we'll finish up to this one today. Okay, and rest of the class you guys are doing practice and review for the ionic compounds. Okay, let's go ahead and start that. Okay, for a covalent bond, each atom will share 1 or 2 or 3 electrons. 1 is single bond, 2 will be double bond, and 3 will be what? Triple bond. Okay, so here chlorine, we know that chlorine has 7 electrons. It needs 1 more. That means it will it will share how many more electron? One more. It has already 7 valence electron, need only one more. So let's go ahead and see how the drawings are done. Okay, so first we will draw all the 7 electron of this chlorine. Okay, and the same thing for the other chlorine. And you can see I draw a ring here, they are sharing electron. Okay, so this is the shared pair. This one is possessed by both the atoms. And how many pair of electrons are there? Just one pair of electron. After that, we will draw a one line which indicates how many pairs are representing. So when two electrons are shared, which is one pair, we will call what bond? We will call that is a single bond. Already bond is there. It is a single bond. Okay, so I'm going to show you how to draw the drawing covalent compound molecules. So first we are drawing, we need to calculate the first rule. First to calculate the total number of valence electron for each atom and choose the central atom. Okay, how will you decide central atom? So usually central atom will have less valence electron. Exception, hydrogen, which is the smallest atom, hydrogen will never be in the center. Hydrogen will never be in the center. Okay. Okay. Then first to choose a central atom, which is, I can also say another rule if you are confused with that. So the least electronegative atom. So we know that the periodic table, highest electronegativity is here. So lowest, always the atom from the left side will come in the center. But one exception, if hydrogen and carbon is there, we know that hydrogen is a special position. Hydrogen will never come in the center. That is only exception. Okay, so next rule, join the atom with a single bond. Each bond, one bond represents how many electron? 2 electron. Join the atom with single bond. Okay. Then there will be leftover electrons. To give them, we are giving the leftover electrons as lone pairs to each atom until everything get 8 electrons. So first you have to satisfy all the atoms around it. Okay. So surrounding atoms are called outside atom. First I'm going to write that. Surrounding atom. Okay, then fill the what? Central atom. So we know that they are sharing electron to get the octet, and there are, remember the exceptions. Okay, hydrogen, boron, beryllium, those are the exception. We already wrote that. Okay, hydrogen needs only how many electrons? 2 electrons. And also add the other rule one more time here, so that if it is beryllium, it need only 4, and if it is boron, it need only 6. Those are the exceptions. Okay, if you are doing like that, distributing electron, if you run out of the electron, we don't have enough electron, then you are moving the lone pairs to share between two atoms. That's how we are making what? Double and triple bond. I know the rule is confusing, but when you do the example, you will understand how to do that. Okay, let's do the starting from CH4, easy ones. Okay, I can't rotate this one. Let me see, I can. Yes, sorry. So CH4. So just pick the central atom. So carbon and hydrogen. So we know that carbon is here, hydrogen is here. Left side is hydrogen, but hydrogen will never come in the center. Okay. So the central atom will be always what? Carbon. Carbon is in the center. Okay, we decided. Now we have to calculate the valence electron. Okay, so I'm going to calculate the valence electron. The abbreviation I am using VE. Okay, let's do that. Carbon. Carbon is in 14th group. So how many electrons there? 4 electrons. And here there is only one carbon. So I multiply with the 4. Okay, we are done. Plus hydrogen is in group 1 electron. How many hydrogens are there? 4. So just to multiply, this is 4 plus 4. 4 electron from here. 4 electron from here. Total how many valence electron? So we don't have space. Let me adjust that. It will be 4 electron plus 4 electron. So total how many valence electron? 8 electrons. So that is the first step you have to do it. Okay. After that, draw the central atom at the center. Okay, this is the central atom. Okay, carbon is called the central atom and hydrogen is called the surrounding atoms, outside atom. So there are 4 hydrogens, so I would go place this one like around it. Don't worry about the shape. We are going to learn the shape later. So 4 hydrogen. Then second rule says draw single bond. So I draw 1, 2, 3, 4. Okay, now there is a problem. We know that each bond, okay, each bond is how many electron? 2 electron. So there will be 2 here. You don't need to draw that like 2. I'm just showing so that you will understand. So how many electron we used? So we already used 2, 4, 6, 8. We had only how many? 8. That means we are done with the structures. Right, let me go back. The page is somewhere. Yes, I think I'm here. Okay, yes. So that means your structure is correct, and check whether both atoms are happy. That is the final thing you have to do. Okay, so I'm going to get another color. So see, hydrogen always need 2 electrons. So hydrogen, this hydrogen has 2, this hydrogen has 2, this hydrogen has 2, this hydrogen has 2. They are happy. Now look at carbon. Okay, carbon has how many electrons? Carbon also has 8 electrons. So I'm going to write all hydrogen has 2 and all carbon, 1 carbon has 8 electrons. So they both are happy. That means just a double tap, your structure is correct. Okay, that was easy one. Let's do the crazy one now. NH3. Okay, first step, always need to valence electron. Nitrogen 15th group. So we know that how many electron? 5 electron. There is only 1 nitrogen, so I'm going to multiply with 1 plus hydrogen. There is 1 electron, and how many hydrogen? 3. So multiply with the 3. So it will be, just cross the parenthesis. So 5 times 1, which is 5. 3 times 1 is 3. Total how many electron? 8 electron. And central atom, hydrogen will never come in the center. So the next one is only nitrogen. So I'm going to write nitrogen at the center. And there are 3 hydrogen. Just put anywhere around it. I'll just put like this. Then we said next rule, connect with a single bond. Now let's see the electrons. Okay, we had how many electrons? We have 8 electrons. So each bond is 2. This is 2. This is 2. This is 2. How many? They are 6 electrons. So how many left over? We have 2 more. Now check are all the atoms are happy or not. Okay. So this one hydrogen has 2 electrons. This hydrogen happy. This hydrogen happy. This hydrogen happy. Look at the nitrogen. Nitrogen has how many now? Only 6. The 2 from here, 2 from here, 2 from here. It needs 2 more. We know that we have 2 more electrons left over. So that electrons will go to the central atom as a pair of electron. So I'm going to draw that here on the nitrogen, which is not shared by any atom. It is completely owned by nitrogen. So that is called lone pair. They are alone. They don't have a partner. That's why we will call them lone pair. They are stronger than the bond pairs. So these guys are called bond pair. Okay, now all hydrogen has 2 electron. Nitrogen is also has 8 electron. So just put a tick mark. Your structure is correct. Okay. Let's go do the next one. Maybe, yeah, next one. H2O. As always, the first step, you have to calculate the valence electron, okay? So, hydrogen has 1 electron times 2, okay? Plus oxygen, which has 6 electron, and there is only 1 oxygen. So, it is 2 electron plus 6 electron. Total how many? 8 electron. Okay, central atom. Remember, hydrogen will never come in the center, so only the atom left over is oxygen. So that is easy for you to decide which one comes in the center. So let's go ahead and select the central atom, which is oxygen. And there are 2 hydrogens. I'm going to write 2 hydrogens on 2 sides. Connect with single bond, equally long. Okay, now see the electrons. We had 8 electrons. Okay, we used how many? There is 2, 4. We used only 4. Now let's see, are all these atoms are happy or not? Hydrogen is happy because it has 2. This hydrogen is also happy because it has 2. But what about oxygen? Oxygen has only how many? Oxygen has only 4. It needs 4 more. Okay, let's see. We used 4. There is 4 remaining. So I'm going to give that 4 electron as pairs, lone pair, to the central atom. So we are going to give a pair of electron here, a pair of electron here. Always do lone pairs on the same side. Okay. So there are 2 lone pairs and 2 bond pairs. Now both of them are happy because oxygen has now 8 electron and hydrogen also has 2 electron because they are sharing 2 pairs. So now double tap. Your structure is correct. Good. Okay. I'm skipping this one because this is similar to the first one, okay? Similar to the first one. Almost, not 100%. Maybe I'm not writing it. Then maybe you will draw the same thing, okay? Don't make that mistake. I will do that, okay? Let's go ahead and do that. Okay, let's calculate the valence electron. Silicon is in 14th group, so 4 electron. 4 electron times 1 silicon, okay, plus fluorine is 17th group, 7 electron. At this point, you all need to memorize the valence electron. That will be easy. That will save your life, okay, or use the periodic table. So 4, this is 4 electron plus 7 times 4, which is 28 electron. Total how many? Wow, 32 electrons. Okay, that is a lot. Okay, now let's decide the central atom. We said central atom will be always from the left side or least number of electron, which is silicon, which the fluorine has on the right side. Okay, fluorine is here, silicon is here. So I'm going to draw the central atom now. We need more space, so adjust your space. Okay, silicon. And how many fluorine? 4 fluorine. Just place 1, 2, 3, 4. Okay, next step, draw single bonds. Okay, so let's see how many electrons we used. We used 2 here, 2 here, 2 here, 2 here. We used how many? 8. Okay, now we have so many electrons remaining, almost 24, and Silicon is happy because it has 8 electrons. But look at the surrounding atom. Fluorine has only 2. It needs 6 more. So I'm going to give lone pairs to fluorine. 1, 2, 6. So now look, this fluorine is happy. It's total 8 electron. Do the same thing here too. That is also happy. This one is also happy. We have to check whether we have electron in the bank or not. Okay. Now let's see. I used 6, 6, 6, 24, 24 plus 8, 32. I used all my electron. Now you have to check whether all the atoms are happy. This fluorine is happy because it has 8. This fluorine is also happy. This one is also happy. This one is also happy. Okay, now I'm going to check my silicon is happy or not. Yes, silicon is also happy because it has 8. So, all the atoms, so silicon has 8 electrons. Fluorine, all fluorine also has 8 electrons. So, double tap, your structure is correct. Good? Yay! I just want to do some double bond. We don't have any examples like that. Oh, that is unfortunate. Okay, I think we have more examples on the next page. Yes. Yeah, there is more. Okay, we'll get there. Okay, so now let's do NC. I'm not doing this one. You can do this as a homework, okay? Because it is kind of similar to this. Not 100%. I'm doing the exception, which has what? Incomplete octets. So we learned beryllium and boron will not have octet, okay? So write that first somewhere, otherwise we will make mistake, okay? Beryllium will need only 4 electrons. And boron, this is also next. Boron need only 6 electrons. Keep that in mind, okay? Okay, now decide the central atom, beryllium and fluorine, which will come in the center. Beryllium will be on the center. Oh, we didn't calculate the valence electron. Let's go calculate that. Sorry. So beryllium is in second group, 2 electron, and there is only 1 beryllium, okay? Plus fluorine is in 17th group, 7 electron. You can put ES or E. Sometimes I'm not consistent sometimes, okay? Don't worry about that. Just 7 electron times 1. So it is 2 plus 7 electron times 2, okay. 2 plus 14, so total how many electrons? 16 electrons. Okay, 2 electrons plus 4 electrons. Okay, now we have beryllium as the central atom. And there are 2 fluorine, so write fluorine, draw the line. Okay, so we have 16 electron. We know that there is only 2 electron here, 2 electron here. So fluorine needs 6 more. So I'm going to give 1, 2, 3, 4. 1, 2, 3, 4. So 6. Now check. We used all the electron. We used 8 here, 16. We don't have anything remaining. We used all electron. I'm going to check. Fluorine is happy. Yes, this fluorine is also happy. Now check beryllium. How many it has? It has only, beryllium has how many? Beryllium has only 4 electrons. Fluorine has how many? 8 electrons. Okay. So don't draw a double bond, but think about the exception. Okay. What was the exception? Beryllium is needed only how many electron? Beryllium needed only 4 electron, and it is correct. So our structure is correct. Okay. So I'm skipping this one for you guys to try. Only thing you had to remember, this one need only how many? That needed only 6 electron. Okay, that is the exceptions. Okay, Now there is something called expanded octets. So some of the atoms will show, especially the non-metals from this side, okay, the bottom side, they are bigger. They can have more than 8, okay. Note the first elements, like this is like phosphorus, sulfur, chlorine, and about everything below that, all non-metals below that. Okay, they can form octets which is more than 2. Okay, let's do one example from there, and then I will go teach you the